Hello everyone. What I'm going to do in this recording is I'm going to cover answers to these problems with multiple questions and different components. And what I'm going to do is I'm going to go over it in a video recording. We're going to do the first problem in this first recording, and then the second one will be done in the second, and the third will be done in the third. So let us begin. The first word problem says that Angela decides to take a walk in her neighborhood. She first walks 6 meters east, then 12 meters north, where she decides to sit and watch the people pass by. What is her displacement from her house? And describe her displacement in terms of magnitude and direction. Well, this one is a simple problem. And the first thing that we're going to do is we're going to do a scale. So we're going to use a scale of 1 box is equal to 1 meter for this one problem, okay? So we're going to begin by placing Angela at a location. Call this the reference point. So this is Angela's location at the beginning without any movement from her location. So that is her location, a dot, a single point in space and time. So the first problem is that she walks 6 meters east. So 6 meters is 6 boxes. So we count 1, 2, 3, 4, 5, 6. So here she has walked 6 meters in the eastward direction. So we draw an arrow, and there she is, 6 meters. Then she takes 12 meters north. Now 12 meters north would be 12 boxes up this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I apparently did not make this long enough. So what I'm going to do is I'm going to count going downwards instead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. Okay. So I'm going to move it going downward rather than going up so that I can have the same displacement. Now, just my placement should be going up this way. I just drew it wrong in this demonstration. Now, I wanted to know what her displacement was. So the displacement is actually the distance from the beginning point to the end of where she had stopped moving. So what I'm looking for is I'm looking for this distance right here. So this would be her displacement, or the distance from the reference point. So remember, displacement measures how far away from the reference point the person is. So what I'm looking for is the magnitude and direction for this line here, which is very easy to calculate. So we know that this is going to be 6 meters, and we know that this is 12 meters. Now, in the notes, we gave you the equation that the resulting magnitude value is equal to the square root of x squared plus squared. So we can actually use this formula. Now, using the triangle, if we locate this as A and this as B, the formula becomes A squared plus B squared, which would be the same thing as this. Only thing is, here we're recognizing that the 6 is in the X direction and that 12 is in the Y direction. So now we use this formula. We just basically plug and chug by doing that the R, or the displacement that we're looking for, is equal to the square root of 6m squared plus 12m squared. So now we take out the calculator, okay? And what we place in the calculator is exactly that. We do the square root, open parenthesis, 6 squared, close parenthesis, plus, open parenthesis, 12 squared, close parenthesis, and we do equals and we get this number of 6 and the square root of 5. If we press this button here with the double arrows, we will get the actual number to be 13.4 meters. So this distance is going to be 13.4 meters. Now, the question is, what is the direction that Angela is in? Now, Angela, in order to do that, we have to use the secondary formula that we learned, which is arctan of B over A. In this case, we would have arctan 12 meters over 6 meters. Okay? Now this would be positive because it's actually going up. The reason why I had to draw it down was because I didn't have enough room over here. So we know that both numbers are positive. So we're going to calculate the number. So the number becomes arctan. We hit this button twice to get the arctan. Then we plug in 12 divided by 6, enter. And we get an angle of 63.4 degrees. So that means that from the first angle, going this way, from the first angle going this way, it should actually be going up this way. Because again, this line should be going up that way. That this angle here is 63.4 degrees. So we can say that Angela is 13.4 meters from the reference point (63.4 degrees) north from east. Or you could even say north of east. So what this basic statement says is that if we have a line in the eastward direction, it is going to be 63 degrees north of east. So it would be 63.4 north of east. And then we draw the line that way with the magnitude of 13.4 meters.